So, these we can write as these value, generally whatever the value we are getting, this can be derived as some value. What is this value? Directly I am just writing this thing 4 into q max. How this value will come? This also I will show you. This is actually root over of pi by 2 root a for this first integration, then for second integration this will be root over of pi by 2 root b, and for this third integration this is root over of pi divided by 2 root c. From here generally what we can get, this 4 cancel out. What are the things you are getting? You can write as q max divided by 2 pi root pi divided by a square root of a b c. So, from here you can easily find out what is the value of this q max. So, q max you can write as eta v I, that is q into 2 square root of a b c divided by pi root pi. This you should keep it in mind. Now, how this, what it is called, how this integration of, what it is called 0 to infinity minus a x square dx is coming as what it is called half into root over of pi by root a, these things how it is coming, that I am now going to show. Let us consider g is equal to, let us here I am just here itself I am deriving this thing, let us consider g is equal to integration of 0 to infinity e to the power minus a x square dx. Similarly, g also can be written as this g itself further for y axis we can write as 0 to infinity e to the power minus you can write as a y square dy, this also we can write, correct, because a is a parameter only, g can be written as along x axis like this, along y axis like this. So, from here what are the things you can write? G square you can write as integration of 0 to infinity, this I am just 2, this 2 I am multiplying, what are the things I am getting? X square into integration of minus a y square dx dy, correct. So, this we can write as integration of 0 to infinity e to the power minus a into x square plus y square dx dy, this you can write. This thing further you can write as what? Let us consider, here I am drawing, this is our x axis, this is our y axis, and let this is our radial axis r, which makes an angle, let us theta. Okay. So, from here in terms of r, what is the x component you can write? So, you can write this is your r cos theta, and this you can write as, these coordinates you can write as r sin theta, correct. These are the things we can write. So, this r cos theta and r sin theta, this idea you got. From here generally what we can get, very interesting things we can get here. So, from here what are the things you can write? X square plus y square you can write as r square, correct. Apart from these things we can write this dx dy is equal to your you can write r dr d theta, r dr d theta. How it is coming, that I am going to discuss. Okay. So, this r dr d theta how it is coming, little bit in next slide I am just showing, then it will be more clear to you how this r dr d theta is coming as this. So, what we observe that this is our x axis, this is our y axis, and let us consider this is our r, this is theta, this is actually r cos theta, and this is you can say r sin theta. So, we can write dx cross dy, we can write as dx dy sin theta. This is very well known to you. This is the cross product. So, from here what are the things we can write? Dx dy we can write as dx cross dy divided by sin theta. This we can write from this equation. So, what is dx? X is equal to got as r cos theta. So, what is dx? So, dx you can write as dr cos theta, you can write as minus r sin theta d theta, correct. So, dx we got, then what is dy? Y we know as r sin theta, from here y we know as r sin theta. What is dy? Dy you can write as dr sin theta, then plus r cos theta d theta. So, these are the things you can write. So, these things now I am going to put in this equation. In this equation number, this is equation number A. So, in equation number A I am just going to put these things. So, what is dx dy we are getting? So, dx dy we can write as dx cross dy. So, dx we got as directly I am writing this thing dr cos theta, from this equation dr cos theta minus r sin theta d theta cross dy you can write as dr sin theta plus r cos theta d theta, okay, divided by what? Divided by this whole divided by this whole divided by you can say sin theta is there. This you should keep it in mind. So, now I am just multiplying this thing, then it will be more clear to you. So, first this with this, what are the things we are getting? Dr cross dr will be there. So, this will be 0. Then I need to multiply this with this. So, you can say minus r sin square theta, you can say d theta cross dr, correct. Now, I will multiply with second term with this first term. So, first term with second term I will just multiply. What are the things will be there? This will be plus you can say r cos square theta dr cross d theta, correct, and I will now multiply with this second term with this second term. So, what are the things we are getting? This will be minus d theta cross d theta will be there. So, it will be also 0, because d theta cross d theta means it is 0. This whole divided by you can say 1 by sin theta. Now, here what are the things you see? This d theta dr we know according to this cross product principle, we can write d theta cross dr is equal to minus dr cross d theta, this we can write. So, once we do these things, what are the things we are getting? R sin square theta minus dr cross d theta, okay. So, minus minus it will be plus and plus this r cos square theta dr cross d theta, correct. So, this will give us r, you can say sin square theta plus cos square theta. Okay. This is whole divided by sin theta is already there, 1 by sin theta is already there. So, this I am writing here, okay, that will be better. So, I am writing these things into dr cross d theta, correct. So, from here what are the things we are getting? We are getting this is equal to your r into 1 into dr cross d theta divided by sin theta. This all divided by sin theta is there, correct. So, this will give us what? R. Again dr cross d theta we can write as dr d theta sin theta divided by sin theta. This sin theta cancel out. What are the things we are getting? R dr d theta. So, I think you got this idea how dx dy. So, we can write as how dx dy from equation A, dx dy equal to, you can write as r dr d theta. How it is coming? This thing is proved. Okay. So, this is coming from this equation, you can say. So, how this thing is coming, you got the idea, clear. Now, so we will go to now on previous slide. So, dx dy, how this is coming as what it is called r dr d theta, that you got, as well as x square plus y square. So, I am just representing 0 to infinity e to the power minus a r square. Instead of dx dy, what are the things we can write? This we can write as r dr d theta. I think it is very clear to you how it is coming. So, here generally what we will do? Here we will do some, just this you can write as this, there will be double integration, definitely there will be double integration 0 to infinity 0 to infinity 0 to infinity, because x and y term is there. So, here also 0 to infinity will be there, this double integration will be there. So, this you can write as integration of what? Integration of, here d theta generally, here always you should keep it in mind. Once we convert these things in terms of theta, then it's this 0 to infinity will convert to this theta will be varying from 0 to pi by 2, and your r is varying from 0 to infinity. This you should keep it in mind. So, here once we converted these things in r theta, then what happens here, this first terms you can say. So, this I am writing, so this will be pi by 2. So, integration of 0 to pi by 2 d theta will be there, and for this r terms it will become, you can say 0 to infinity e to the power minus a r square, you can say e to the power minus a r square dr, and here also will be a r. Clear? I think it is very clear to you. Now, here we will just do some calculation, this then it will be more clear to you. This from here generally if you will do some calculation, you will get a very interesting things. Let us consider. So, this calculation I am just going to do in next slide, then it will be better for you. So, what are the things we got? We got g square is equal to, you can say integration of integration of 0 to pi by 2 d theta, and for r it is 0 to infinity 0 to infinity r e to the power minus a r square dr. This equation we got from previous slide itself I have shown. So, let us consider here, let us consider a r square is equal to u, let us consider. So, what are the things here we can get? A into 2 r dr you can say is equal to du. So, dr you can write as du divided by 2 r a. It is very clear to you. Now, from this also you can get, let this is on another equation, let this is equation b. Here you can get if r is equal to 0, u equal to 0, limit also you can give, if r is equal to infinity, u also equal to infinity. This you can get from this equation b itself, limit you can get, how this limit is coming. So, this I am just putting here, what are the g square you are getting? G square you can write as integration of this will be theta. So, here if it is theta, then it will be pi by 2 minus 0, and another integration that will be 0 to infinity. So, r there will be generally e to the power minus u, and dr you can say du by 2 r a. So, this r cancel out, cancel out. So, this will be generally you can write as pi by 2 a, So, integration of minus a means this will be generally you can say, this I am just doing minus e to the power minus u, it is varying from 0 to infinity. This will give us you can say, so this will be pi by 2 and pi by 2, this will be another 2 is also there. So, you can say pi by 4 a, this will be generally you can say minus 0 plus 1. This you can, if you will do, then it will get. So, it is giving us pi by 4 a, clear. So, g square is equal to pi by 4 a. So, what we got? G square is equal to pi by 4 a. So, what is g? G you can write as pi by square root of pi divided by this a. So, this is for generally for x component. Similarly, what we can get? Similarly, for 0 to infinity, what it is called e to the power minus b y square dy, this we can easily calculate as integration of pi by 2 root b. Similarly, for integration of 0 to infinity e to the power minus c into zeta square d zeta, this will give you integration of pi by 2 root c, correct. So, this idea you got how this previous equation, these are the square root of pi divided by 2 root a, square root of pi divided by 2 root b, these are the things is coming. So, you got what is q max value. This q max value we got, okay. Once q max value we got, now we are going to find out what is called equation of double ellipsoid for moving coordinate heat source. For finding out this moving coordinate heat source and defining this a capital A B C, here you need to apply some you can say boundary condition. What are these boundary condition that I am now going to discuss, okay. So, this boundary condition how we can discuss. So, for that, so what we got to find out this A B C generally, what are the things we need to put some boundary condition. or you can say we need to put some condition. What are those conditions that I am going to write this thing. So, to evaluate the constant, to evaluate the constant A comma B comma C, the semi axis of the ellipsoid A B C in the direction of x, y, zeta are defined such that the power density falls to 5% of Q max value, 5% of Q max value. What does it means? That means this semi axis ABC, this we define such a way, so that our end of this semi axis, our power density is 5% of Q max value. This you should keep it in mind. So, this Q max value where it is? At the surface of the ellipsoid, this you should keep it in mind. Okay. This is very important thing, because this generally define as the ABC, as well as it is also defined as, it is also used based on this condition, the constants terms A, B, C, capital A, B, C. This you should keep it in, how it is, everything in details. That means, whatever the power density we are considering, this power density we are considering up to 2 sigma, you can say around 2 sigma position. What I am telling, understand? That means, along x axis, instead of considering this infinite distribution, we are concentrated our power density distribution, where the value is actually goes up to around this that 2 sigma means around 95%. 95% means where the value of, whatever the value of this Q will be, this Q will be, let us it is 100%, peak is, maximum is, Q max is 100%, it is 5% of that things. Okay. So, this you should keep it in mind. So, this is the condition we will impose. So, for by using this condition, what you can do for, you can say for the direction of x axis, what we can find out, direction of x axis, where generally direction of x axis, where generally y equal to 0 as well as zeta equal to 0. For first we will find out A value, what we can write as, you can write as Q max e to the power minus A, capital A into a small a square, this a small a square, this value should be equal to what? 5% of Q max value. 5% of Q max value means you can write as 0.05 Q max, correct. This is very simple derivation, you can say, very simple relation. So, this Q max both side will be cancelled out. So, from here what are the things you can get? You can get 1 by e to the power a square is equal to, you can write as 1 by 20. So, from here you can write as ln 20 is equal to your, both side I am taking ln e to the power a into a square. So, a square you can write as ln 20 So, this from here you can write as A is equal to ln 20 is approximate value is around 3 divided by A square. Similarly along y axis, generally B will give us a value which is 3 by B is capital B is equal to 3 by B square. Along zeta axis you can say C will give you 3 by C square. This you should keep it in mind. So, what are the final equation we got now? So, the final equation, what is the final equation we got? In previous slide I have already shown Q max is equal to you can write as, in previous slide itself I have shown 2 into Q divided by pi root pi square root of A B C, 2 Q into divided by this. Okay. So, you got this Q max value, and in the initial equation, that is equation number 1, we got that our Q is a function of this power density distribution x, y, zeta into T. You can say this is equal to, we can got as Q max into e to the power minus a x square into e to the power minus b y square. This is our generally double ellipsoidal heat source equation. Initially we got these things into minus c into zeta square. Okay. This is the initial heat source equation we consider. In this equation, if we put the what it is called Q max value, what are the things we will get? X, y, zeta, t. This will be equal to, you can say Q max is equal to 2 Q square root of A B C. What is A B C? So, you can write this is your A B C divided by pi root pi, okay, into all these things are there. So, this will give us 2 Q. Now, from this generally A B C, what we will get? A is equal to 3 by A square, B is equal to 3 by B square, and C is equal to 3 by generally C square. Okay. This divided by pi root pi into integration of minus A equal to, you can write as 3 x square by A square into e to the power minus 3 y square by B square into e to the power minus C means 3 by C square into zeta square. Okay. So, from this what are the things you are getting? You can say 6 root 3 Q divided by pi root pi A B C, okay, into this. So, this is the equation, overall equation of this double ellipsoid. Now, generally for considering this front portion of the ellipsoid and back portion of this ellipsoid, this equation can have two parts. What are those two parts? That I am just going to show. Generally this two part will be directly here I am showing. So, for front part, so you see this is the equation what? For moving coordinate heat source. This is the equation for, this is the equation, let us consider this is equation number 4. So, this equation number 4 is for moving coordinate system, this you should keep it in mind. So, what should be the heat source model for fixed coordinate system? So, for fixed coordinate system, instead of zeta we should use z plus v into tau minus t. If we put generally, then whatever the q x y, instead of zeta there will be z t. This you should keep it in mind. This equation will be, then what happens, at least all the terms will be there, 6 root 3 q divided by pi root phi a b c, then e to the power minus 3 x square by a square, e to the power minus 3 y square by b square, and at last there will be, instead of zeta, there will be z plus v into tau minus t whole square divided by c square. This you should keep it in mind. Now, this equation generally is, this equation, this equation number, let us consider 5, this is equation number 5, this is for fixed coordinate system, fixed coordinate system. Now, this equation can be written in two parts, one is for front part, another one is for back part. So, what is this front part equation and back part equation, that I am just showing. In front part equation generally what are the things will be there, directly I am just showing these things. Okay. So, this front part of this equation for moving coordinate system will be, just there will be a factor, you can see ff, this factor how it is coming, I have already told you, this factor ff generally is, ff is coming, ff is generally 2 into cf divided by cf plus cr, and what is the fr, fr is equal to 2 into cr, 2 into cr divided by cr plus cf, this you should keep it in mind. So, for front portion of this heat source equation, generally it is represented at qf, where generally ff is multiplied, and instead of c there you need to use cf, instead of c there you need to use cf, and here also instead of c you need to use cf, this you can see from this equation. And for rear portion of this ellipsoid you need to apply this heat source equation. So, here generally there we have to apply a fraction fr, how this fr is coming I have already shown, and instead of c there you have to use cr, here also you have to use cr. This is for moving coordinate system. For fixed coordinate system generally zeta is converted in terms of z, how it is coming, and there also you need to use, there also you need to use, because here this eta is not required, because q itself I have considered as eta vi. So, there I have already incorporated this efficiency terms eta, that is why I am just eliminating this term. If you consider q is equal to only vi, then this eta terms, efficiency terms also will be there. Okay, this you should keep it in mind. So, how this equation is coming, you got the idea. So, this is the details derivation of double ellipsoidal heat source model. Okay. So, this is the detailed derivation of double ellipsoidal heat source model, which is derived by Goldak et al. That is why it is called Goldak double ellipsoidal heat source model, because once you know the detailed derivation of this heat source model, then rest of the things you can easily find out, actually you can say. So, this is called Goldak double ellipsoidal heat source model, which have wide application in the field of welding for prediction of thermal history. Next lecture I will start from here, and I will discuss about other heat source models. Thank you.